Right, this is question 10 of the 2018 paper. This one's quite a standard question and comes up quite frequently, so it's a good one to be able to knock out, I suppose. First part is evaluate the line integral and show the circulation is zero. Okay, so we're going to integrate this thing, u dot dr. So the first thing is to identify what r is, and for each segment of the line integral a, b, bd, and ad, you get a parametrization. Parametrization, it's very hard to say. And I can't say it. So you get the parameters for these, and first one then, x is at -1, y is alpha, and z is 0, so that's handy. In fact, z is 0 for all of them, so that simplifies the problem quite a lot. So we're just replacing the vector r, xi plus jk plus zk with these parameters. So that means that the first thing we're going to have is that r is equal to minus I plus alpha j. Okay, so that's fine so far. If we differentiate that with respect to alpha, we just get j. And the trick of it is to integrate r dot dr by doing dr by d alpha times d alpha, which the d alphas then cancel. And you end up with just dotting by j. So if we dot this by j, we just want to dot 2x plus 4y. But x is -1, y is alpha, so it'll be -2 plus 4 alpha. That we're going to integrate with respect to alpha. So that's that. U dot dr, the alpha. We're going to integrate between -1 and 1 because that's the parameter we're given. And so we just integrate it, -2 plus 4 alpha. Because it's -2 there and 4 alpha there. And integrate that, well, that's just going to be -2 alpha plus 2 alpha squared, which evaluated between 1 and -1 is -4. That's it. So for the AB part, the value is -4. Then do exactly the same thing for BD. We're going to replace R by beta x and 1j and again 0k. And then differentiate it, which means that's just going to become beta I. So I've skipped that process. Just got there beta I. Sorry, not beta I, but 1 is beta I, and differentiate with respect to beta becomes I. Everything else becomes 0. So we're dotting it with I this time. So dotting with I is going to be 2x plus 2y plus 2z. Well, there is no z. X is beta, so it's 2 beta, and y is 1, so it's 2. So it's 2 beta plus 2. But we're going to integrate. So there's that, 2 beta plus 2, d beta, which becomes, of course, beta squared plus 2 beta. Again, between 1 and -1, or -1 to 1, which also just gives 4. Okay, so far. So on the next page, we're going to have, while it thinks about it, there you go. We're going to have the same thing. This time the R vector, just look at the conditions again, are going to be x, y is gamma, z0, so that means that we're going to have r equals gamma I plus gamma j plus no k. Differentiate that, and we get that with respect to gamma I plus j. So we're going to dot I plus j, so we're going to have this term, and we're going to have this term. And since it's all basically gamma, that's 2 gamma plus 2 gamma is 4 gamma, plus 2 gamma plus 4 gamma is 6 gamma. So it's 4 gamma plus 6 gamma, which is 10 gamma, which we then integrate with respect to gamma between the same limits, -1 to 1. So I've written it out there, 4 gamma plus 6 gamma is 10 gamma. Integrate that, 10 gamma squared over 2, which is just 5 gamma squared, which is basically 5 over 2, and 1 minus 1. But 1 takes -1 squared. 1 taken away 1 is 0, so it's going to give 0. Now one thing I haven't mentioned there is that we need to integrate actually back, not from a to d, but d to a, because we go from a to d this way, a, b, b to d. And then for a closed loop integral, which this is, we need to go back to a, and at the moment this is actually ad. So whatever answer we got here, we'd actually take the negative value. But in this case it's 0 anyway, so it has no effect. But if it was a different question, with let's say the answer was 2, we would take it to be -2. So we got in the first two answers 4, -4, and 0, and so they add up to the closure integral of those three things is 0, which is what it asks for in the question. If we go straight to part 2 now, show that any circulation is 0 for any closed curve. Here we just take the curl of u, so we just curl u. I did that in a previous video. It's quite a lengthy procedure, so I won't go through it again, but it's just the same thing as you do for what I did in another question. We need to find the vorticity. You do exactly the same thing, find the curl. So it's pretty much the same thing for that.